Okay, so this is the second part of the 4.4C video, just to complete the notes on page 158. So you've already done number 3 from the previous video, or I should say 3A. So I'm going to start on 3B. So 3B says the rate of water flow can be approximated by this Q of t. So notice that that's a rate. So up on part A, they just gave me the table of values for the rate, but down here on part B, they're actually giving me the equation. So Q is the rate. It says to use this equation, use Q, use the rate, to approximate the average rate of water flow. Okay, to approximate the average rate of water flow. So this, you can use the concept of average value. You can think of this as the average value of water flow. All right, so we're thinking of this as the average value of the rate. Okay, so remember how up above we said if you want the average value of F, you're actually integrating F. So if I want the average value of the rate, I need to be integrating the rate. So I need to be integrating Q. So this average value is going to be, let's see, 1 over B minus A. So 1 over, and they said the 24-hour time period. So the B minus A is going to be like 24 minus 0. All right, my pen is doing weird things here. See if I can fix that. Sorry. So let's see, 24-hour time period. So A to B would be from 0 to 24. So integral from 0 to 24. And like I said, if we want the average value of the rate, then we're going to be integrating the rate. So we're going to be integrating that Q of t function. And I'll let you do this in your calculator, but I just wanted to kind of show you the setup. All right, so look at number 4. Actually, we're going to be comparing number 4 and number 5 because you have to read carefully what function you're given. You know, are you given a rate or are you not given a rate? So number 4 says a bar of metal is cooling from 1,000 degrees to room temperature, which is 20. The temperature H of the bar after it starts cooling is given by this function. So this function that they give me that they're calling H, is that a rate or not? Well, it says the temperature H. It doesn't say the rate of change of the temperature. So H is like an original function. It just represents the temperature, not the rate. So on letter A, when it says find the temperature of the bar, that just means find the value of the H function, and then it says at the end of 1 hour, meaning when t equals 1. So the notation would be, I just want to know what is H of 1. I'm not integrating H. I just want to plug 1 into H. So in other words, it's going to be 20. And again, you could use your calculator. 20 plus 980 times E. If I put in a 1 for t, it's going to be E to the negative 0.1. And again, you can put that in your calculator and see what you get. Okay. Letter B says, find the average value of the temperature. Well, remember, whatever I want the average value of is what I'm integrating. If I want the average value of the temperature, then I'm integrating the temperature. And remember, they told me the temperature is the function H. So if it's over the first hour, my 1 over B minus A is going to be 1 over 1 minus 0. And I know I didn't need to write that out, but I wanted you to see my A and my B. Integral from 0 to 1. And then the temperature function is just the H. It is just the 20 plus 980 E to the negative 0.1 T. Okay, so again, I'll let you use your calculator and come up with that. I just want to talk you through kind of the setup. So in this case, on number 4, the function we were given was not the rate. It was the original function. Okay, let's compare that to number 5. Talking about a cup of coffee. This looks like the one we did before, but it's different questions. A cup of coffee at 90 degrees put into a 20-degree room when T equals 0. So they're giving me an ordered pair for the temperature. The temperature is going to be 0, 90. Okay, that's the temperature of the coffee. It says the coffee's temperature is changing at a rate of this. So this time the function they give me is not just the temperature function, it's the rate of change. In other words, it's the derivative of the temperature. So letter A says, find the coffee's temperature when T equals 10. Well, this is what we did yesterday in class when we used that adjusted version of the fundamental theorem. So if I want to find the temperature at 10, I'll say, instead of T for temperature, I'll say C for the temperature in Celsius. So the temperature at 10 is going to equal the temperature at, my C's are looking like parentheses, sorry. It's going to equal the temperature at time 0 plus the amount of change from 0 to 10 of that rate function. So of R of T. And of course, you can fill in the 90 for the C of 0 and do your integration and simplify. All right, so in this case, we were given the rate function and being asked to find the original temperature. So that's why we had to integrate. Okay, letter B says, find the average rate of change. Now, I want us to do something with this. Based on what we've been talking about, okay, if I want to, I could think of that average rate of change as the average value of the rate of change. If I think of it that way, whatever I want the average value of is what I'm integrating. So if I want the average value of the rate, I'm going to be integrating the rate function, right? Let's see, over the first 10 minutes. On this one, since T is in minutes, the first 10 minutes would be from 0 to 10. So it's going to be 1 over 10 minus 0, 0 to 10. Okay, so that's one way to find the average rate of change, finding the average value of the rate. Now, let's compare that to our old days version of rate of change, right? Remember how we used to say the average rate of change of the temperature is going to be the temperature at time 10 minus the temperature at time 0 all over 10 minus 0, right? That's the way we talked about average rate of change before. Well, does it make sense that that is the same as what I wrote over here in green? Are these the same thing? Well, remember, R was the rate of change of C, right? So if you integrate R, isn't that going to take you back to the original temperature function, C of T? And if I evaluate that from 0 to 10, wouldn't that be this C of 10 minus C of 0, right? Fundamental theorem says first you plug in the 10, then you plug in the 0. Well, where does this 10 minus 0 come from? Well, right here, right? If I have a 1 over 10 out in front of that, isn't that just like putting 10 on the bottom? So do you see these are the same thing? So in this case, you're like, well, then why did I need to use that average value? Well, I needed to use average value because in order to do it this way, I would have had to know the actual temperature function, and I didn't. I only knew the rate of change of the temperature. And we'll develop that concept a little bit more when we get to the next day or so. But in this particular case, the most straightforward way to do this problem would have been to use the average value formula. Okay, so hopefully those few extra examples will help go through the 4.4C homework.